So in this question, you have like a 3x3x3 cube that is made of 27 normal dice, and each die's opposite sides sum to 7. Want to know what is the smallest possible sum of all the values visible on 6 faces of the large cube? So this is kind of like a weird question, right? So if we're going to draw our 3x3x3 cube, it would look something like this. So this is like 3x3x3. And then basically we know that the each die's opposite sides has sum of 7. So clearly we know that each die has like the numbers 1 through 6 labeled on it. 1, 2, 3, 4, 5, 6, right? So we want to like find the sum. We want to maximize the sum on all the faces that are visible. Like want to maximize the sum on this face, the sum on this face, the sum on this face, and the 3 hidden faces, right? So the idea kind of is like we can kind of consider each of these separately, right? So we can kind of group each of these cubes into 3 different like categories. The first category is if it's the center of a face. Like for example, this red cube here, this red cube here, and this red cube here. You can kind of think of them as like the centers of the faces of the cubes. And clearly, if we want to maximize the sum of the numbers there, we clearly want each of those numbers, each of those red squares to represent a number 6, right? Like you want all of those to represent 6 because 6 is the largest possible number you can get. So, and we know that there are going to be 6 of these like kind of like middle squares. Let's call them like middle squares. So there are 6 middle squares, and each of these squares can be a maximum of 6. So 6 times 6 would give 36. And now what we can do is we can consider like kind of like these blue cubes now, like these cubes that are like, you know, they're kind of like on the they're kind of like shared between two edges, or between an edge, like these blue cubes here. We can group those as a group too. Notice that there are going to be 12 of these blue cubes, right? There are 12 of these blue cubes because like we see that like the top we can kind of think of this 3x3x3 cube as like being consisting of 3 like layers, right? There's a top layer, the middle layer, the bottom layer, and each layer consists of 4 blue cubes. So we're gonna have 12 of these blue cubes in total for this 3x3x3 cube. So we have 12, and for each of these like blue cubes, the maximum sum, because each of these blue cubes, so let's take a look at like this blue cube here. We have like 2 faces, right? You have a face like, so you have 2 faces. You have a face like here, and you also have a face here. So basically we have 2 numbers that we have to place there. So obviously if we want to make the sum as large as possible, we should make those 2 numbers 5, 6, and 5, right? To make it as large as possible. Oh, actually, wait, the original question asked for the smallest possible sum. Hold on. Yeah, wait. If the question asked for the smallest possible sum, then like, wait, this number should be 1 over here, right? Because like we want the smallest possible sum. So like this number here would be like 6. And if you want the smallest possible sum, then these 2 numbers, instead of 6 and 5, that would be like the largest sum. You would want 1 and 2. So that would give like 36. And then we can see that there are like kind of 8 of these like kind of corner cubes, right? Like we can color them green, like these corner cubes here. And then we have 8 of those corner cubes. And if we want to minimize the sum on those corner cubes, we would want to place the numbers 1, 2, and 3 on them, right? To make the sum as small as possible. Because each corner cube, like let's say this cube here, it contributes 3 like faces kind of that are visible. So 8 times 1 plus 2 plus 3, that'd give like 48. So if you add these numbers together, you get 6 plus 36 plus 48. And that would give you like an answer of like 92 or 90. And that would be your answer. So that would be choice D, which should be the right answer. Yeah, so I think this question was just like, you can kind of, to organize your counting, this is kind of a counting question sort of in a way. Like you want to organize your counting, you want to group them based on like, you know, the middle squares, like the squares at the center of each face the kind of like edge cubes, right? The cubes that are like shared between an edge, these blue cubes in this case. And we also have the corner cubes, like the green cubes. And for each cube, we consider it separately and find what is the smallest possible sum that you can form.